Hello and welcome to Algebra 2 tutorial. With this video we're going to take a look at quadratic modeling. So these are going to be problems that have a scenario with them, word problems, application problems that use a parabola. And so there's one specific scenario that we always use for this: projectile motion. If you kick something in the air or throw something in the air, hopefully you've realized that it takes a parabolic path through the air. And so whenever we have something that does that is falling, we can use a quadratic equation with an x squared to model its path through the air. So we're going to be looking at kicking footballs, soccer balls, throwing basketballs, etc., etc. Anything that is flying through the air can be modeled with a quadratic equation. So that's our big topic here. Now there's two ways we're going to do that. Sometimes if you have the vertex and the point, so the vertex is the highest point on the parabola, and you have another point somewhere else, that's enough information to write a modeling equation. Sometimes you don't have the vertex though, so you have to use the x-intercepts and a point. That is also enough information. And we're going to be using two of our types of quadratic equations: vertex form, which hopefully that's pretty obvious we'll use here, and factored form, because factored form gives you the x-intercepts. So first, the easy one, if you have a vertex and a point. So here we have a soccer player kicking a soccer ball over a wall where the player is standing 10 feet from the wall and wants to kick the ball 30 feet in the air to clear it. So on all of these, the first thing you probably want to do is draw a picture. So that's what we're going to do. So here the ball is starting, and we'll kick the ball up. Do the best I can for a parabola here, and here the ball lands. And the best way to do this is to have the wall be right in the middle at the highest point. So here is the highest point right there, and we need the wall is 30 feet, and we're standing 10 feet away. So this distance right here is 10 feet, and this distance right here, because a parabola is symmetrical, will also be 10 feet. Now, we've got most all of our information in here. It's time to make a couple decisions. Where are we going to put the x-axis, and where are we going to put the y-axis? The x-axis is, there's not much debate there. There's no reason why you wouldn't just make this your x-axis. But we do have some decisions to make for the y-axis. There are two good possibilities. We could make the y-axis right here at the beginning, right where we kick the ball. That's a good idea. The numbers work out pretty nicely if you put it right there. Another good option is if you make the y-axis the wall. That will also be a pretty good decision to do that. So either of those will work. The numbers won't be the same, but they will still both be correct. And so either way you choose will be correct. I'm going to do this one because I think it's a little bit easier in my opinion. So that's our y-axis, and that is our x-axis. Now that we have that, let's put in the rest of the numbers for these points. So this point right here at the origin is 0, 0. This point where the ball lands, we've gone a horizontal distance of 20 feet, so the x is 20. But we're back on the ground, so the y value is 0. And this point, our vertex at the very top, horizontally we've gone 10 feet. But vertically, we are up 30 feet. So there we put all the numbers in. Now it's time to write the equation. This is going to be pretty easy because we know the vertex, and we have an equation called vertex form. A times x minus h squared plus k. We have the left and right movement and the up and down movement right there, and we know all of those from our vertex. So this parabola has been moved 10 units to the right, so x minus 10 in our equation. And it's been moved 30 units up, so it's plus 30 on the k value. And you can see we only have one thing left, the a value. So we have to solve for a. So we need one other point to do this. And we actually have two to pick from. We can either do 0, 0 or 20, 0. I think 0, 0 might be easier. Smaller numbers are oftentimes easier. So into the x's we're going to put 0, and into the y we're going to put 0. So 0 into y. Into x we're also putting 0. Now that I've got those two filled in there, hopefully you can see we only have one variable left, and we should be able to solve for it. So let's simplify this. 0 minus 10 is negative 10, squared is positive 100. Bring everything down, and then we're going to do this two steps in our head. Minus 30 to the other side means there's a minus 30 on that side, and then divide both sides by 100. So we're going to divide both sides by 100. And we get a is negative 30 over 100. The zeros cross out. And so a is negative 3 over 10. So we now have all the parts of our equation. Y equals, our a value is negative 3 over 10. And hopefully the negative makes sense because our parabola is, in fact, upside down. X minus 10 squared plus 30 is our k value. So there we have a quadratic equation that models the path of this ball as it flies through the air. So when you know the vertex, you almost always want to use vertex form. So that's our first way of doing a modeling problem. One more. What if we don't know the vertex? So we're going to do the same thing, but we're only going to know the x-intercepts plus some other random point that is not the vertex. So again, we got our soccer player, and we're kicking the ball over a wall. So suppose the person is standing at the point 1, 0. So we're making this a little bit more difficult because we're not standing at the origin this time. So I'm going to start with a picture. So here's my y-axis and my x-axis. And we are standing at the point 1, 0, which is right here. And we're trying to kick a ball over a wall that is 5 feet away. So if I go over 5 feet, that would actually put me at 6. And so that it lands 14 feet away. So if we start at 1 and we go 14 feet away, that would make us landing at the point 15. Now hopefully you can see that 6 is not actually in the middle between 1 and 15. So the middle is going to be right about here-ish. So I'll draw my parabola coming down. But we do know this point right here. The ball will need to be 10 feet high when it clears the wall. Alright, so right here at 6 is where the wall is. And when it clears this right here, that needs to be 10 feet high. So the y value is 10. So we have 3 points. Our first point here, 1, 0, 15, 0. But now we also know this point, which is not the vertex, sadly, is the point 6, 10. So we can't use vertex form because we don't know the vertex. We have to use factored form because factored form tells me my two x-intercepts. So my first x-intercept is 1. That means this will have to be x minus 1. That gives me an x-intercept of positive 1. And the next one will have to be x minus 15 because that will give you 15 as an x-intercept. The one thing that we need still, it looks like it's done, but it's not. There is an a value right there. So again, just like the previous one, we need to solve for a, which means we're going to plug in another point. Now we already used the 1 and the 15, so now we have to use the 6 and the 10. So 6 will go in for x, and 10 will go in for y. So we don't know what a is. I have an x here, that will be 6 minus 1, and another x, so that will be 6 again, minus 15. And now we have one variable left over, and we should be able to solve for that. So let's simplify. 6 minus 1 is 5, and 6 minus 15 is negative 9. And so 9 times 5 is negative 45. Divide both sides by 45, or negative 45, sorry. And that will again have to be negative. You can turn that into a decimal if you want, but you don't need to. So our final equation is 10 over 45, make sure that is negative, x minus 1, x minus 15. So using factored form, we're again able to write an equation that models the path of this ball through the air, but we didn't need the vertex. We just needed the starting point, the ending point, and then some other random point on the parabola. All right, those are the two easiest ways to model a quadratic equation, something flying through the air. We had two options there. If you know the vertex, the highest point, plus another random point, or if you know the x-intercepts. They can both be used for quadratic modeling. All right, let me give you a practice one here. Try that one out. I would recommend drawing a picture first, labeling all the information, and then choose which equation to try to use, the vertex form or the factored form. Good luck.